Right now, as you're watching this, there's an object moving through our solar system that has scientists completely baffled. And I'm not talking about your typical space mystery where we shrug and say, that's weird, and move on. I'm talking about an object that, according to the math, according to physics as we understand it, should not exist in the form we're observing it. Either it's shattered into at least 16 separate pieces during its closest approach to the sun, or we need to seriously consider that what we're looking at isn't natural at all. Here's why this matters to you. On December 19th, 2025, just a few weeks from now, we're going to find out the answer. Telescopes around the world, including the Hubble Space Telescope and the James Webb Space Telescope, will turn toward this object and give us the clearest view we've ever had. If they see fragments, case closed. It was a comet that broke apart. But if they see one intact object, then everything changes. Because if it survived intact, then the laws of physics as we apply them to comets completely break down. And we have to ask a question that most scientists have been terrified to even whisper. Is this thing artificial? I'm going to walk you through exactly why this is the most important astronomical observation of the decade, and I'm going to show you evidence that even the skeptics can't easily explain away. But here's what I need you to understand before we dive in. This isn't some blurry UFO video. This isn't conspiracy theory nonsense. This is Harvard professor Avi Loeb doing the math and concluding that we have a genuine paradox on our hands. Numbers that don't add up. Energy that shouldn't exist, surface area that's 16 times too small for what we're observing. And by the end of this video, you're going to see why some very serious scientists are starting to wonder if we just watched an interstellar probe execute a maneuver around our sun. Let me start with the problem that changes everything, the problem that makes this more than just another space rock passing through. On November 9th, 2025, Avi Loeb published calculations that should have made every astronomer in the world stop what they were doing. The numbers he presented weren't subtle. They represented a paradox so profound that it threatens everything we thought we understood about this object called 3I/Atlas. That's what we're calling it. 3I/Atlas, the third interstellar object ever discovered. The first was Oumuamua back in 2017. The second was Comet Borisov in 2019. And now we have this. Here's the paradox in the simplest terms possible. To lose the amount of mass that 3I/Atlas lost during its closest approach to the sun, to create the jets and the activity that we observed, this thing needed to absorb a massive amount of solar energy. We're talking about 3 times 10 to the 18th joules. That's 3 followed by 18 zeros, an incomprehensible amount of energy. And to absorb that much energy, you need surface area, lots of it. The calculations show that 3I/Atlas would need to have a diameter of about 23 kilometers to absorb enough sunlight to produce the mass loss we observed. That's not a guess, that's straightforward physics. Solar radiation delivers 700 joules per square meter per second at the distance this object reached. To sublimate 5 billion tons of carbon dioxide ice over the course of a month, you need that 23-kilometer diameter to catch enough sunlight. Here's the problem. The Hubble Space Telescope imaged 3I/Atlas back in July 2025. Scientists analyzed those images carefully. They determined that the maximum diameter of this object is 5.6 kilometers, not 23 kilometers, 5.6 kilometers. Do you see the problem? The object is 16 times too small. Not twice too small where you could blame measurement error, not 3 times too small where you could invoke some weird geometry, 16 times too small. The required surface area to explain what we observed is at least 16 times larger than what actually exists. This is where Avi Loeb draws a line in the sand and says there are only 2 possibilities. Either 3I/Atlas broke apart into at least 16 pieces, dramatically increasing its total surface area by creating many smaller fragments, or something other than simple solar heating is driving the mass loss. There is no third option. The math doesn't allow for one. Think about what fragmentation would mean. When a comet breaks apart, each piece has its own surface exposed to sunlight. Suddenly, instead of one 5.6-kilometer sphere, you have 16 or more smaller objects, each sublimating independently. The total surface area skyrockets. The energy budget problem disappears. Everything makes sense again within the framework of natural comets. But here's what keeps me up at night, and here's what should make you pay attention. What if it didn't break apart? What if December 19th arrives and Hubble shows us one single intact object with no companions, no debris field, no string of fragments? Then we have a different kind of problem. Then the question becomes, how does an object with only 5.6 kilometers of diameter produce mass loss that requires 23 kilometers of exposed surface? And the uncomfortable answer is that there's no natural explanation. None. Unless the mass ejection we're observing isn't coming from ice being heated by the sun, unless it's coming from something else entirely. Let me paint you a picture of what happened as this object rounded the sun, because the timeline here is absolutely wild. Back in August 2025, the James Webb Space Telescope observed 3I Atlas and measured its activity. At that time, the object was losing mass at a rate of 150 kilograms per second. That's normal for a comet, nothing unusual. Scientists looked at that data and thought, okay, we're observing a large interstellar comet approaching the sun. Textbook stuff. Fast forward to late October, the object reaches perihelion, its closest point to the sun about 150 million kilometers away. And suddenly, everything goes crazy. The mass loss rate explodes to approximately 2 million kilograms per second. Let me repeat that. 2 million kilograms every second for weeks. That's the mass of 2,000 cars being ejected every second. The increase isn't gradual. It's not proportional to getting closer to the sun. It's 4 orders of magnitude. 4 orders of magnitude means 10,000 times more material being ejected than what Webb observed just months earlier. When something changes by a factor of 10,000, you know that something fundamental has changed about the system. Either the mechanism driving the mass loss is completely different, or the object itself underwent some kind of transformation. For a natural comet, this could happen if outer layers suddenly cracked open, exposing fresh, volatile ices underneath. It could happen if the object started disintegrating. But to go from 150 kilograms per second to 2 million kilograms per second requires such an extreme change that even comet scientists who study this stuff for a living are scratching their heads. And here's where the alternative explanation starts to sound less crazy. If 3I Atlas has engines, if it has some form of propulsion system, then the timing makes perfect sense. You cruise through interstellar space with minimal activity, just enough thrust to maintain your trajectory. Then when you reach the sun, when you're deep in the gravity well moving at your highest velocity, you fire your main engines. You execute what's called an Oberth maneuver. It's basic orbital mechanics. Every spacecraft engineer knows that burning fuel at perihelion, when you're moving fastest and deepest in a gravity well, gives you the maximum change in trajectory for the minimum amount of propellant. If you were designing an interstellar probe and you wanted to adjust your path through a solar system, perihelion is exactly when and where you would fire your engines. The 4 orders of magnitude increase fits perfectly. Before perihelion, minimal activity, conserving fuel. At perihelion, full thrust, maximum propellant flow. After perihelion, throttle back down. This profile matches what a spacecraft would do far better than what a natural comet would do. But wait, there's more strangeness, and this is where things get really bizarre. On November 8, 2025, astrophotographers captured detailed images of 3I Atlas. What they saw was stunning and deeply weird. The object showed at least 7 distinct jets emanating in multiple directions. Not one jet, not 2, at least 7 separate streams of material, each following its own trajectory away from the nucleus. Some of these jets pointed toward the sun. Let that sink in. Jets pointing toward the sun? That's called an anti-tail. And while it can happen through optical effects with comets, having multiple jets in seemingly random directions is extremely unusual. For a normal comet, you might see 1 or 2 jets from active regions on the surface that are heated by sunlight, maybe 3 if the comet has a really complex surface. But 7 or more jets pointing in many different directions, that suggests something fundamentally different about either the structure of this object or how it's ejecting material. Here's why this matters. If you have 7 jets pointing in random directions, their thrust vectors partially cancel out. To produce the non-gravitational acceleration that 3I Atlas exhibited, where the object's trajectory changed in a measurable way, you need much more total mass ejection than if all the thrust was aligned in one direction. It's inefficient, it's wasteful. Unless those 7 jets aren't wasteful at all. Unless there's 7 different thruster systems on a spacecraft. Main propulsion providing the bulk of velocity change. Auxiliary thrusters maintaining stability and orientation. Reaction control thrusters for fine adjustments. This is exactly how complex spacecraft are designed. The Space Shuttle had dozens of small thrusters. The Apollo command module had multiple reaction control systems. Any sophisticated spacecraft needs the ability to maneuver in multiple directions. What looks like chaotic, inefficient outgassing from a natural comet perspective starts to look like sophisticated, controlled propulsion from an engineering perspective. Now, I know what you're thinking. This all sounds circumstantial. Where's the smoking gun? Where's the definitive proof? And you're right to be skeptical. That's why December 19th matters so much. But before we get to that, I need to tell you about something that happened in October that a lot of people don't know about. Something that adds a whole other dimension to this mystery. On October 2nd and 3rd, 2025, 3I Atlas passed within 30 million kilometers of Mars. NASA's Mars Reconnaissance Orbiter has a camera called HiRISE, one of the most powerful cameras we've ever sent to another planet. When pointed at 3I Atlas from that distance, it should have achieved resolution about 3 times better than the best Hubble image. The observations were conducted, the data was transmitted back to Earth, and then the images disappeared. Avi Loeb requested them. He got no response. Other researchers inquired through different channels. Nothing. The images were simply not released. The government shutdown that began October 1st provided a convenient excuse. NASA was closed, personnel were furloughed, data processing was offline. But here's the thing. HiRISE data from routine Mars observations continued to be released through automated systems during the shutdown. So why were the 3I Atlas images specifically held back? It got weird enough that Congresswoman Ana Luna from Florida had to get involved. She wrote a letter to NASA's acting administrator on October 31st urging immediate release of the data. She had a call with NASA officials on November 6th. The fact that congressional intervention was necessary to get NASA to even discuss an interstellar object is itself extraordinary. Now, I'm not saying NASA is covering up alien technology. The most likely explanation is bureaucratic dysfunction, or maybe the images are disappointing and don't show anything new. But the lack of transparency creates exactly the kind of vacuum that conspiracy theories exploit. And when you combine missing images with all the other anomalies we're seeing, people start to wonder. What were those images supposed to show? If 3I Atlas fragmented, the HiRISE images might have captured the breakup in progress or shown early separation of fragments. If the object was intact, the images might have shown structure or features that NASA wanted to analyze internally before making public. We don't know, and that uncertainty is maddening. Here's something else that deepens the mystery. Radio telescopes detected something that many people pointed to as proof this is just a comet. On October 24, 2025, South Africa's Meerkat radio telescope array detected hydroxyl absorption lines from 3I Atlas. Hydroxyl is a classic signature of comets. When water molecules in a comet's coma are broken apart by solar ultraviolet radiation, they produce hydroxyl radicals. If you detect hydroxyl, you have water, which means you probably have a comet. Case closed, right?
Not so fast. Yes, hydroxyl detection confirms water is present, but it doesn't tell you where that water came from or how it got there. A natural comet sublimates water ice from its nucleus, but a spacecraft could also produce hydroxyl signals if it carries water. Water is an excellent radiation shield. Water can be used as propellant. Water can be used as coolant. If 3I Atlas is technological and vents water vapor as part of its operations, that water will dissociate in sunlight exactly like comet water, producing hydroxyl that radio telescopes can detect. The key isn't whether hydroxyl is present, the key is how much is present and what that implies about production rate. If the hydroxyl signal corresponds to billions of tons of water being sublimated per month, we're back to the energy budget problem. The object doesn't have enough surface area. If the signal corresponds to modest amounts consistent with a spacecraft venting vapor, then the detection is ambiguous. The reports from Meerkat don't provide detailed production rates. They just say hydroxyl was detected, which is a classic comet signature. True, but incomplete. It doesn't resolve the fundamental questions. And this brings us to the observation that will answer everything. December 19th, 2025. Circle that date. That's when 3I Atlas makes its closest approach to Earth. On that day, the object will be about 269 million kilometers away, roughly 1.8 astronomical units. In astronomical terms, that's close. Close enough for ground-based telescopes to resolve fine details. Close enough for Hubble to capture images at maximum resolution. Close enough for Webb to perform detailed spectroscopy. The question December 19th will answer is simple and profound. Is 3I Atlas one object or many? Did it survive perihelion intact, or did it fragment into pieces? If Hubble images show a string of fragments separated by thousands of kilometers, each with its own coma and tail, then 3I Atlas was a natural comet that broke apart under stress. The energy budget problem is solved. The 16 times surface area discrepancy is explained. Mystery over. But if Hubble shows a single intact nucleus with no companions, then we have a major problem. Then the energy budget paradox remains. Then we must ask how an object with only 5.6 kilometers diameter can produce mass loss requiring 23 kilometers of surface area. And there's no natural explanation for that. Avi Loeb has stated explicitly that if 3I Atlas maintains structural integrity, we must consider it to be something other than a natural comet. This isn't speculation, it's logical deduction from physical constraints. The math doesn't allow for a 5.6-kilometer ice ball to sublimate 5 billion tons of material per month using solar heating alone. Let me explain why propulsion makes the energy problem disappear. Chemical rockets expel exhaust at 3 to 5 kilometers per second. That's about 10 times faster than comet ice sublimating at 0.4 kilometers per second. To produce the same thrust, a rocket needs only 1/10 the mass that a comet would need. Ion thrusters are even better, achieving exhaust speeds of 10 to 50 kilometers per second. An ion thruster needs only 1% of the mass to produce the same momentum change. If 3I Atlas is using any form of propulsion, the mass loss we observed could be explained by expelling far less material at high velocity. The 16 times surface area problem vanishes because the energy isn't coming from the sun anymore. It's coming from an internal power source, a reactor, an engine, technology. And here's the really unsettling part. Loeb calculated that if 3I Atlas followed a random trajectory through space, the probability of it aligning within 5 degrees of our solar system's ecliptic plane is about 1 in 200. The probability of it being as unusually large as it is, given that we should see thousands of smaller objects before finding something this big, adds another layer of improbability. When you combine these factors, the odds of 3I Atlas having a natural origin and just randomly showing up the way it did come out to less than 1 in 100 million. 1 in 100 million. That's not impossible, but it's extraordinarily unlikely. It means either we got spectacularly lucky, or this object isn't a random visitor. It's a targeted one, something sent deliberately on a trajectory optimized for studying planets in our ecliptic plane. Now, I want to be clear about something. Even if 3I Atlas turns out to be intact on December 19th, that doesn't automatically prove it's artificial. Science requires extraordinary evidence for extraordinary claims. We would need spectroscopy showing exhaust velocities consistent with propulsion, not thermal sublimation. We would need to detect unusual molecules or isotope ratios that don't occur in natural comets. We would need multiple independent lines of evidence all pointing the same direction. But here's what we know right now. We have an object that's 16 times too small to do what we observe it doing. We have mass loss that increased by 10,000 times in a matter of months. We have 7 jets pointing in different directions like a multi-thruster system. We have trajectory changes consistent with propulsion. We have statistical odds of 1 in 100 million for this to be a natural random occurrence. And we have missing images from Mars that might show us something NASA isn't ready to share yet. Individually, each anomaly might have a natural explanation. Collectively, they paint a picture that doesn't fit our understanding of comets. The spectroscopy scheduled for December will measure the velocity of material in the jets. If those velocities are a few hundred meters per second, thermal sublimation is confirmed. If they're several kilometers per second or more, we have a problem. The composition analysis will reveal whether the jets contain normal comet molecules or something unexpected. The imaging will show us once and for all whether this object is in one piece or many. Think about what we're living through right now. We have an interstellar object exhibiting behavior that challenges everything we thought we knew. We have credible scientists proposing it might be technological. We have observations consistent with both natural and artificial interpretations. And we have a specific date when critical observations will resolve at least some of the ambiguity. This doesn't happen often in science. Usually, questions remain open for years or decades. Here, we have a definitive test on a known date. In a few weeks, we're going to point every telescope we have at this faint dot of light crawling through space, and we're going to see what it reveals.
If it's fragments, we'll breathe a sigh of relief and file 3I/Atlas under unusual but natural comet that broke apart. If it's intact, then the conversation changes fundamentally. Then we have to seriously consider that what we're looking at survived conditions that should have destroyed any natural comet. That it has structural integrity suggesting engineering. That it executed a maneuver at precisely the optimal point in its trajectory. I keep coming back to those numbers. 16 times too small, 4 orders of magnitude increase, 7 jets, 1 in 100 million odds, December 19, 2025. These aren't conspiracy theories. These are measurements, physics, mathematics, the universe telling us something that we might not be ready to hear. Avi Loeb has been careful to say that the most likely outcome is still that this is a natural comet. His papers include caveats that the analysis is largely meant to stimulate thinking and motivate observations. He's not claiming certainty. He's claiming the question is open and deserves serious investigation without prejudice. And that's all I'm asking you to consider. Not that aliens definitely visited us, not that we should jump to conclusions, just that we should look at the data honestly, follow the evidence wherever it leads, and be willing to ask uncomfortable questions if the observations demand it. Because here's the thing. If 3I Atlas is natural, we learned something fascinating about how interstellar comets behave under extreme conditions. If it's not natural, we learned that we're not alone in this galaxy, that other civilizations exist and have achieved interstellar travel, that their spacecraft occasionally pass through our solar system, possibly studying us the same way we study them. Either answer is profound. Either answer changes how we see the universe. The only wrong answer is refusing to look because we're afraid of what we might find. So watch the news in mid-December. Pay attention when Hubble and Webb release their observations. Check if those Mars HiRISE images finally get declassified. Read the spectroscopy reports when they come out. This is happening in real time. We're living through what might be the most important astronomical observation of our generation. 3I Atlas is still out there right now, moving through our solar system at 150,000 miles per hour. It's getting closer to Earth every day. And in a few weeks, we'll have our best and possibly last chance to see it clearly before it recedes back into interstellar space forever, carrying its secrets with it. The integrity test is coming. The universe is about to give us an answer. We need only have the courage to accept what the data reveals, even if that answer challenges everything we assumed about what interstellar objects can be. Whatever 3I Atlas turns out to be, it's already given us something invaluable. It's forced us to question our assumptions, to look more carefully, to measure more precisely, to think more openly about what we might find in the vast darkness between stars. And maybe, just maybe, it's teaching us that the universe is far stranger, far more interesting, and far less empty than we ever dared to imagine. December 19th is coming. The telescopes are ready, the universe has an answer waiting, and humanity is about to take one more step toward understanding whether we're alone in this cosmos or whether we share it with minds and civilizations that have been exploring the galaxy long before we ever looked up at the stars and wondered. The data will tell us, the math will speak, and whatever truth emerges from those observations, it will be worth the wait. If this blew your mind, hit subscribe because we're covering every development on 3i Atlas as it happens, and this story is far from over.